In this problem, we're going to try to find the following limit. The limit of this sum with k going from 1 to n of k over the square root of n squared plus k squared. The easiest way, I believe, is that we can trap this sum between two limits or two sequences, and we see if we can apply the squeeze theorem. But doing so, we have to do some algebra. We need to do some bracketing of these sum. Okay. Now, given that k is between 1 and n, we can square k squared to have 1 k squared between 1 and n squared, and adding n squared to both sides, we have n squared plus k squared is trapped between 2n squared and 1 plus. So here this is it's trapped between 1 plus n squared and 2n squared. Now if we take the square root, nothing is going to change since the square root is increasing. So we're going to have n squared of 2. We flip everything. We have n squared plus k squared between 1 over 1 plus n squared and 1 over n squared of 2. What do we need now? We need this k here. Okay, we need this k, so we multiply by k, and since k is positive, nothing is going to change, and this is the formula that I need. So I'm using a special color for that. So here k over 1 plus square root of 1 plus n squared, and k over n squared of 2. Okay, now I know this, my sum is trapped between these two. If I sum up now I can sum up here k from 1 to n. So I'm gonna keep the 1 inside because that's the one that I need. And here this 1 over square root of 1 plus n squared doesn't depend on k. So I'll take it outside, and I have this sum k going from 1 to n, and here I also have this 1 over n square root of 2 doesn't depend on k, so I have the sum k going from 1 to n of k. Here I'm almost done, except that I need to know this value here in terms of n. The same thing for this one here. So I know that let me write, I'm gonna call my sum now. So I have to write it this way. So I don't want to call it any other thing because I need to take the limit. Okay, k going from 1 to n. Okay, here this sum is sum of the k's between 1 and n is n times n plus 1 over 2 square root of 1 plus n squared. The same thing here on the left side. So I have n times n plus 1 over 2 square root of 2 times n. Okay, so I'm almost done, except that I have to take the limit. So now if I take the limit, so I'm gonna call this one here, I'm gonna see that here I can cancel by n here, since n is bigger than 1. So I'm gonna cancel by n. I'm gonna have this sum here. Okay, so I'm gonna compute this sum on the left. I'm not gonna worry about this one here. Okay, so this is clearly if you take the square root, it's gonna get you something. But here from down that I need. So I'm gonna have as I take the limit. So this one here. So now I can take the limit here. If I take the limit, I'm gonna have the limit of n plus 1. Okay, and this 1 over 2 square root of 2, I take it outside. I'll take the limit here. So what's this limit here? As n gets bigger, what do we get? Plus infinity. So here, what's this limit here? So here I'm gonna do it this notation. N goes to infinity. Okay, so here this one is bigger than infinity. What values can it have? So if this one is bigger than infinity, what's its limit? So if this one is infinity and this one is bigger than infinity, so what's the limit? So this limit, therefore I conclude that the limit of this sum, k going from 1 to n of k over the square root of n squared plus k squared is infinity. And this ends the question. So here, the answer here is that I have plus infinity. Okay, so we use the squeeze theorem. Okay, the other limit is infinity here. This one is infinity. So here, this is trapped by plus infinity and plus infinity from above and below. What's its limit? It's plus infinity. So therefore, my limit here is plus infinity. Okay, if you see any errors or mistakes, please let me know. Okay, and please like, share, and subscribe for more. Thank you.